Okay, equation of a line. We'll be looking at parallel and perpendicular lines, and lines in general on the coordinate plane, graphing lines. You've done this before in algebra. We'll just need a little refresher maybe?
Yeah.
Yeah? Okay. First thing you want to know is y equals mx plus b is the equation of a line. Okay, it's not the answer to every single question, so don't, some people just will write y equals mx plus b for everything. If you need the equation of the line, it's y equals mx plus b. Okay, the m is the slope, it's how steep the line is, that's the rise over the run. We also have a slope formula, y2 minus y1 over x2 minus x1. So if I give you 2 points, for example, 3, 1 and 6, 8, and I wanted the slope of the line between those 2 points, well, call that x1, y1, x2, y2, and substituting to get your slope. 8 minus 1 over, subtract the x's, 6 minus 3, and you get, simplifies to 7 over 4. Yeah. So that's how I would use the slope formula to find the slope between 2 points. If they give you the equation, yep,
7 over 3.
What? 7 over 7 over 3, you're right. Thank you. 7 over 3.
Wait, where's the y1?
So x1.
Well, I mean, y1 and y2 from mx plus b.
Oh, from here?
Yeah.
So from this equation, you don't have a y. You don't have any points. You don't have a y1 or a y2 or an x1 or an x2. So from the equation, you can get what the slope is directly. It's the coefficient of the x. And then the b is the y-intercept. So for example, if I had the line y equals 2x plus 4, I know right away that the slope of this line has to be 2.
No, I know. I was asking where y2 and y1 came from.
Oh, here? You'd be given 2 points.
Oh, okay.
Okay? So you might be just given 2 points. Otherwise, you'd have to use the equation to calculate the 2 points. But there's no point in doing that because the equation gives you the slope already. But you might have a question that reads something like, find the slope of the line that passes through the points 3, 1, and 6, 8. You don't have the equation of the line, so you can't look for the m in the equation. You would use the slope formula on the points to calculate the slope. Okay? And then the number on the end is the y-intercept. So in this example, the y-intercept is 4. So from an equation, I can find the slope and the intercept. Make sense?
Yeah.
Okay, good. Next, we need to be able to graph the line. To do it, you've got to get the y by itself. So I got some graph paper here. We're going to hand out some graph paper, and you guys are going to try to graph. We'll pass those around.
Do you need a calculator?
No, we are not doing anything on the calculator. Pass those around. Pass those around. So here's our example. Let's take the first one. These up here.
Huh? I can't see it. Wait, why don't you divide y by everything? Yeah. Is that how you do it?
So if I want to do the first example, y minus 2x equals 1, and I want to graph that line, what you need to do is get the y by itself. Just put the phones away.
That's 2x by both sides.
Yeah, add 2x to both sides. You need to get the y by itself, which means you got to undo that minus 2x. If there's extras, pass them up. You pass them back now?
Okay, she needs her. That's mine. Done. 1, 2, 3.
Okay, any more extras? Great. So we're going to add 2x to both sides because we need to get the x by itself.
So y equals 2x plus.
Right. Now that the y is by itself, I can identify the slope. The slope of this line is the 2. And write it as a fraction if it's an integer. I can always put it over 1. That means my rise is 2, my run is 1. That means I'm going up 2, right 1. Okay. And then you're going to count the...
The y-intercept. Wait. Yeah, the y-intercept determines how much you move.
The y-intercept determines where you're starting from. That's your starting point. So the slope, which is 2 over 1, gives me the up 2, right 1. The y-intercept, which is this number 1 on the end, that tells me where on the y-axis I start. So this tells me that I have to start 1 unit up on the y-axis. That's my starting point. Okay, that's where that green point there comes from, that 1, the y-intercept. The slope now tells me from that point, go up to right 1. So from that starting point up to right 1, up to right 1, up to right 1. Yep, you can reverse it, and instead of up to right 1, you can go down to left 1. And it should, I didn't graph that very carefully. I can graph a little bit better. Down to right, down to right 1, down to right 1, down to right 1. And it looks like that. Whenever you're graphing a line, please put on arrows and label it with the equation. This is just algebra. This will be like a building block of a problem. You'll have to be able to graph a line for other kinds of problems. So this part's just like the algebra review. Okay, any question on that one? Should we try the other one?
Yeah.
Okay, let's try to graph 2x plus 3y equals negative 6. Oh, we got there. We'll do this one over here. What do I have to do to both sides? Subtract 2x. It gives me 3y equals negative 2x minus 6. Now what do I have to do? Divide by 3. Y equals negative 2/3 x minus 2. Okay, and dividing 2 by 3, I just write it as a fraction. Now, this is where you've got to be careful with the negative slope. See, I've got a fraction 2 over 3, and I've got a negative sign. Which one's negative, the top, the bottom, or both?
The top one.
Okay, the answer is could be either the top or the bottom, but just don't make both of them negative. So if I have a slope of negative 2 over 3, that means if I want, I can go down 2, right 3, right very nicely over there, down 2, right 3. I've made the 2 negative, so my rise is actually downward, so it's negative 2. My run is positive to the right 3. Or I could say, oh, let the bottom be negative and the top be positive, which would mean up 2, left 3. Okay? Just don't make them both positive. Don't say down 2, left 3. That's not right. Either the top one's negative or the bottom one's negative, but not both. Why can't I make both of them negative? What happens if I have a negative divided by a negative? I get a positive, but it's not supposed to be positive. It's supposed to be negative. Right? A negative divided by a positive is negative. A positive divided by a negative is negative. So either of these works. Just don't make them both negative, otherwise the slope will change to positive, and that's not what it's supposed to be. Okay, so let's do the down 2, right 3. From my y-intercept, which is negative 2. So I'm going to go down 2, right 3.
Wait, I thought you were supposed to go up to.
No, it can
Oh,
go.
I'm gonna use this one. I can use either one. I'll use this top one here. Down 2, right 3. I'll do both. Down 2, right 3. If I want to do that one, I'd go up 2, left 3. And I get to there. So either way, I follow along the line. And that's the line y equals negative 2/3 x minus 2. Okay? There's graphing the line. Get the y by itself. Yep, yes, no.
Can't you graph for the second one a little higher up on the line?
What do you mean graph it a little higher?
Graphing it a little more.
Oh,
There's
extend
more
it further?
Yeah.
Yeah. You can go further if you want. I've got enough of it there. When you're graphing, there's no hard and fast rule about how much of it you have to show. You know, you don't have to go across the entire page. But again, giving me just that much of a line, that's not enough. Give me some of it. You know, make at least a few jumps. You can do at least a couple in each direction. That would be
As long
great.
as it connects to the other line.
Okay, you know, use some common sense there. I'm not going to give any rule for how much of the line you need to graph. Little tiny bit of it, that's not enough. You can do more than that. Okay, next up, parallel and perpendicular lines. This might be parallel lines. Parallel lines, we know from the definition, they're lines in the same plane that never cross. That's our definition. If you want to prove lines are parallel from a proof point of view, you can't just say that, oh, they never cross, because there's no way for you to tell that they'll never, ever, ever cross. That's where we did things like looking at alternate interior angles. If alternate interior angles were congruent, the lines were parallel. If corresponding angles were congruent, the lines were parallel, because that would force them to never cross. From a coordinate geometry point of view, looking at the equations of the lines, another way to think about it is that they have the same slope. In the coordinate plane, if they have the same slope, right, same steepness, then they're parallel. That's what we're talking about here. If the lines have the same slope, they've got to be parallel. So all you need to do is figure out what's the slope of each line, and then you can tell are they parallel. Look at this line. Y equals 2x plus 1. You know the slope is 2. This one, y equals 2x minus 5. The slope is 2. They're parallel lines. They have to be. They have the same slope. So this is an important concept for coordinate geometry. Parallel lines have the same slope. That's going to come up over and over and over again.
Wait, what's done?
Slope. M is our symbol for slope.
Isn't the bell about to ring?
No, we got
You got
6 minutes.
let's see. I have on my clock, on my watch, 5 minutes. We can do this in 5 minutes. We're almost done. The next one is perpendicular. They cross at a right angle. That's our definition of perpendicular lines, lines that form right angles, right? From a coordinate geometry point of view, you can also think of them as lines whose slopes are what we call negative reciprocals. Negative reciprocal slopes. What that means is that you take the slope of one, and if you change the sign and flip it, you get the slope of the other. So here's my example. Y equals 2x plus 1. What's the slope? Positive 2. Right? 2x plus 1. Now I come over to this one. Y equals negative 1/2 x minus 5. What's the slope? Negative 1/2. Watch your signs. Okay. I'm not doing anything. I'm just writing down the two lines. I'm just writing down the slopes of each, and then we're going to check to see if they're negative reciprocals. Now, if I take this one, this 2, and I flip it upside down, what do I get? If I flip it upside down, 1 over 2. And then if I change its sign, what do I get? Negative 1 over 2. Is that the same as that one? Then they're perpendicular lines. Okay, that's my check. Pick either slope, it doesn't matter. Flip it upside down, change the sign. If it's the same as the other slope, they're perpendicular. Okay, so let's look at some examples. This is like what you'll see on the homework. They'll give you two lines, and they might ask you, are the lines parallel, perpendicular, or neither? What you need to do is identify the slope of each. Here's I've got y equals 4x minus 6. Okay, let's see, Elijah, help us out here. What's the slope of the first line? 4. And Elijah, what would I do to get the slope of the second line? I've got a 1 in front of the x, but I want to get, remember we said about finding the slope and writing equation rules? I want to get the y by itself. Yeah, so subtract x from both sides. Now what? Divide by 4. Y equals negative 1/4 x plus 8. Okay, then, are those lines perpendicular? Yeah, because if I take the 4 and flip it upside down, I get 1/4. And then change the sign, I get to negative 1/4. Perpendicular. Okay, we'll stop there. So, the homework is page 180 to 181, numbers 1, 2, 5, and 12 through 15. It's on Power School. I have it in as being due on Monday. If you want to do it tonight and show me tomorrow, great. Otherwise, do it for Monday. What? It's what? Oh, thank you.